IAS toppers study fewer hours than their peers. The physiological mechanism they deploy has been documented in academic literature since 1932. Most students never hear it. You sit at your desk for 10 straight hours. Another candidate studies for 4. You assume the higher volume of work guarantees a higher exam score. Effort alone does not dictate the physical retention of data. In 1932, researcher H.F. Spitzer tested 3,605 students at the University of Iowa, establishing the foundational data for how human memory decays over time. This bar chart contrasts the two groups from that study. The group that compressed their reading into a single massed session retained 28% of the material after 63 days. The group that spaced their reviews out over specific intervals retained 80%. Both groups spent the exact same total amount of time studying. This graph illustrates the biological baseline the massed study group was fighting, the 1885 Ebbinghaus forgetting curve. Without a calculated intervention, the human brain loses 77% of new information within 24 hours. If a high volume of effort fails against this biological drop-off, what mechanism actually succeeds? In 1994 at UCLA, cognitive psychologist Robert Bjork defined a principle called desirable difficulty. Interventions that deliberately slow down the initial learning process produce significantly greater long-term retention. Imagine building a muscle. Lifting a weight you can already lift easily produces no new strength. You must lift at the edge of your capacity, where failure is possible, to produce growth. Spaced repetition is weightlifting for memory. The interval is the weight. Review too soon, no growth. Wait too long, the memory's gone. Time the interval precisely, and the memory becomes permanent. So the forgetting itself, the moment when I struggle to remember something, that struggle is actually the thing that makes the memory stronger? I should be grateful for the forgetting. You should be engineering it. The forgetting is not a failure of your memory system. It is your memory system working correctly. The struggle to retrieve at the right interval is precisely the biological trigger that converts short-term knowledge into permanent, retrievable expertise. IAS toppers do not avoid the struggle. They schedule it. They schedule the forgetting. They schedule the retrieval at the precise moment the forgetting has made it difficult enough to matter. The psychological pain of struggling to recall a fact is not an indicator that you are failing. It is the mandatory biological prerequisite for building a lasting neural pathway. We can observe this mechanism at the molecular level. In 2013, the MIT Neuroscience Lab isolated the exact mechanics of a protein called brain-derived neurotrophic factor, or BDNF. This visualization of a synapse demonstrates the trigger. Retrieving information when it is easy produces minimal BDNF. Forcing an effortful retrieval exactly when a memory is decaying triggers a massive release of BDNF, which physically reinforces the synaptic connection. Research published in Psychological Science by Cepeda and colleagues in 2008 mapped the optimal intervals to maximize this chemical release. You must space your reviews at 10 to 20% of your intended retention period. For a 1-month goal, retrieve the data every 3 to 6 days. For a 1-year goal, retrieve it every 5 to 8 weeks. At Purdue University, Roediger and Karpicke proved the efficiency of this biological trigger. A single retrieval practice session retained 50% more information at 1 week than rereading the same text 3 separate times. The pass rate for the UPSC Civil Services exam hovers around 1 in 1,000 candidates. A 2019 analysis published in Learning and Individual Differences found that top 100 rankers consistently deploy the science, prioritizing self-testing over reading and spaced review over massed study. You sit in an exam room, staring at a blank page. You know you studied that specific chapter for days. You can visualize the textbook, but the answer is completely gone, exactly when it matters. You sit there blaming yourself. You assume your memory is defective, or that you just aren't smart enough to compete. Your intelligence was never the variable in that room. The biology was always available to you. Your timing was simply wrong, and you were never taught how to engineer your own synapses. We standardized this biology using a strict 5-interval protocol. This calendar grid maps the timeline. It requires 0 extra study hours and no specialized applications to execute. There is one unbreakable rule. You must always execute a blank page retrieval first. Write out everything you remember. Only when you are finished do you check your notes. Never reverse this order. Day 1 happens the same evening, within 24 hours of learning the material. Close your notes, write the data from memory. Check for errors, then mark your gaps. This single action secures a 40% retention boost by day 7. Day 3 is your second retrieval. Recalling the data will feel significantly harder than day 1. That difficulty is the exact biological signal required to release BDNF. Day 7 is your third retrieval. Most students who cram have now lost 80% of the material. By following the protocol, your attention remains stable at 60 to 70%. Day 21 marks the fourth retrieval, classifying the memory as medium-term consolidated. Day 60 is the fifth retrieval. The memory is now classified as permanent long-term storage. These 5 calculated interventions systematically break the Ebbinghaus forgetting curve, resetting it at a higher ceiling each time to guarantee retrieval on exam day. While success in any competitive field involves many variables, the molecular biology points toward a specific habit that differentiates how these students approach the same syllabus. The toppers did not study harder than you. They simply stopped reviewing what they remembered and started retrieving what they were beginning to forget.